Okay, we're going to do a podcast here. The video goes along with the Bonding Basics assignment and Atomic Theory, okay, for Mr. Gordon's biology class. The paper looks kind of like this, all right? It's got a front, it's got a back. We're going to be working on the back in this little section right here to start with, okay? Now, the periodic table. It's got a bunch of squares on it that look like this. Okay, that's why it's nerdy. It's got a bunch of squares. Bad joke. Okay, you got 6 and 12 by the carbon. Now, some periodic tables, you could have the 6 down here and the 12 up here. That could be flip-flopped. It doesn't matter. Sometimes this might say 12.01. It doesn't matter. We round, so we're rounding down to 12. What this means is this. This is the atomic number. And it tells me the number of protons. Always. Okay? So the atomic number of carbon is always 6. Always 6 on the periodic table. So carbon always has 6 protons. That can't change. If that number changes, it ceases to be carbon. We're not talking about carbon anymore. If we're talking about something with 7 protons, it's nitrogen. Okay? Now, carbon, this is the atomic mass. The bigger number. The bigger number is the atomic mass. To calculate that, it's going to be protons plus neutrons. Okay, that equals the mass. Now, if it's protons plus neutrons, the periodic table gives me 2 numbers of this math problem. Okay, so protons plus neutrons equals mass. What does the periodic table give me? It gives me the number of protons. Carbon has 6 protons. It has a mass of 12. So, what don't I have? I don't have n. I need to solve for n. Okay, so I'm going to subtract 6 from both sides, and I get 12 minus 6, so n equals 6. For carbon on the periodic table, n is equal to 6 neutrons. That's how you calculate mass, and that works for any of the elements on the periodic table. Now, what if we're not talking about normal carbon, and we're talking about carbon-14. It exists. It's an isotope of carbon. Okay? Well, that changes my mass. So now my mass is 14. So I subtract 6 from both sides, and in carbon-14, my neutrons are equal to 8. So that's how I calculate mass. It always works for any atom. Okay. Now, what the periodic table doesn't tell me from these 2 numbers is the number of electrons. Okay, so how do I know the number of electrons? Well, it's kind of tricky, but not. Carbon here is written as carbon. It doesn't show any charge. When something has a positive charge, you put a positive by it. When something has a negative charge, you put a negative by it. Batteries. Here's a battery. Okay? It's a Duracell battery, possibly. This is the positive end. This is the negative end. It tells you which way to put it into your TV remote. So you know this is the positive end, this is the negative end. I tell you that by putting the charges on the picture of the battery, or the battery itself. Okay? So if I draw an atom like sodium, that means sodium has a charge. Now, none of the atoms on the periodic table have a charge written by them. So we consider them neutral. Okay? If a neutral atom is neutral, it means it has the same of 2 things. The same number of positive charges and the same number of negative charges. Okay? So let's do the math. How do I calculate charge? To calculate charge, I have to take my positives, and my atomic number tells me the number of protons. Protons are positively charged. Electrons are negatively charged. And all electrons have a charge of -1. All protons have a charge of +1. So in carbon, I have my protons plus my electrons equal my charge of carbon. I have 6 protons. Where did I get that number? Right there, the atomic number. Okay? This is actually going to be minus, my bad, minus the number of electrons to give me the charge. The charge up here is neutral. It's 0. Because I didn't tell you otherwise. And so 6 minus what is 0? I know that it must have 6 electrons. Okay? Now, however, what if I am talking about this right here? Sodium. And it's got a positive by it. That means it has a +1 charge. That's what that plus means, +1. That means to get over here, I need a +1 charge. Now, if this was sodium on the periodic table, okay, sodium has an atomic number of 11. So I know it has 11 protons. 11 minus what is +1? 11 minus 10. So sodium, in this form, has 1 fewer negative charges than it has positive charges. So my protons are 1 more than my electrons. 11 minus 10 equals +1. Okay? What about something else here? Chlorine. Chlorine is typically found as a negative. And it's number 17 on the periodic table. Okay? So, I know one thing about chlorine. It's got 17 protons. Now, chlorine has a -1 charge. So we've got to get over here and get -1. So, this would be 18. Okay? Chlorine in this form has an extra electron. It's got 1 more electron, 1 more positive charge than, or sorry, 1 more negative charge than positive charges to give it that charge. Okay? Now, as we work through that, that should basically help you figure out how to calculate mass and how to calculate charge. Okay? Now, the question is, this assignment is called Bonding Basics. So you need to know how elements or atoms bond with one another. Okay? Now, the front of the paper, so we're talking right here on the front of the paper, we've got a new big word. Okay? The word is valence. Okay? Valence means the electrons in the outer
Could we get all
shell.
cross-country athletes to head towards the north end of the building?
The electrons in the outer shell. Okay? So you're going to ask yourself, what in the Hades is an electron shell? Okay? Well, it's where the electrons are found. Alright, so in an atom, you've got the nucleus here, and then on the outside, you've got electrons, and they go in layers. Okay? Kind of like a cake. So, what you need to know about this is, the electron shells can only hold a specific number of electrons. So, the first shell can hold no more than 2 electrons. And the second shell can hold no more than 8 electrons. And the third shell can hold no more than 8 electrons. So if I asked you a quiz question, how many electrons can the first 2 shells hold in total 2 plus 8 is 10. How many can all three hold in total? 18. Simple third grade math. Okay? 18 electrons in the first three shells. Now, the valence electrons, what that means is how many electrons does an atom have in its outermost shell? So back to carbon. Carbon's number 6 on the periodic table. It's neutral. So that tells me it has 6 protons. And it also has 6 electrons. So now we're filling out that table together. Carbon has 6 protons and 6 electrons. But how many of those are valence electrons? So remember, carbon, in its first shell, it can hold 2 electrons, and then that shell's full. So it has to move on to the second shell. And how many do we have left over? Well, we had 6 total. 2 are in the first shell. So carbon has 4 valence electrons in that second shell. 4. Okay? Now, the question is, let's go back here. If it's got 4, the last question on the paper says, how many would it take to fill its outer shell? Well, the second shell can hold 8 total. We have 4, so we could put 4 more in its valence shell to fill it up. Okay? Number 2 on your paper. Number 2, if I remember, is sodium. Okay? Sodium on the periodic table is Na. Its atomic number is 11. So we're dealing with 11 electrons. So how many are in its first shell? 2. How many are in its second shell? 8. How many is that total? 10. How many does sodium have? 11. So sodium in its outermost shell is going to have 1 lonely electron out there in its outermost shell. So to finish the paper, how many would it take to fill its outer shell? 7. 7. Because the third shell can hold 8 total. Okay? We'll do one more. Chlorine. Chlorine is number 17. So you are dealing with 17 electrons. So chlorine, okay, it's got 2 in its first shell, it's full. It's got 8 in its second shell, it's full. It's got 10 so far. It's got 17 total. So 17 minus 10, it's going to have 7 electrons in its outer shell. Okay? In its valence shell, it has 7. And so how many would it take to fill it up? You can put 1 more in that outer shell. Okay? Turn the video off, finish that table with your periodic table, and then when you're done, turn it back on. We're going to go to bonding. Okay, now, I will do a couple of these with you. And you will have to do the rest on your own. We will start with number 1, H2. Now, H2 means I've got 2 hydrogens in a molecule. It's hydrogen gas. Okay? Now, what I have to do is ask myself 3 to 4 questions every time I do one of these. Okay? So, hydrogen, find it on the periodic table. It's number 1. So, hydrogen is number 1 on the periodic table. That tells me a couple of things. It has 1 proton and 1 electron. Right? So the question is, here's hydrogen. It only has 1 electron shell, and there's 1 electron floating around in that shell. So how many does it need to fill its shell? So there's my first 2 questions. Number 1, how many does it have? How many do I have? 1. So the second question, how many do I need? Hydrogen can fit 2 electrons in that outer shell, so I need 1. Third question to ask yourself, who else is coming to the bonding party? Well, I've got 1 more hydrogen coming. It's hydrogen 2. So this hydrogen over here is going to come over and help this guy out. Okay? Well, if this hydrogen needs 1 more electron, and there's 1 more hydrogen coming to the party, how many is it going to bring to the other one? 1. So this hydrogen also has 1 electron in its outer shell. So what happens is, they get close together, and they will actually share these electrons, so they both feel like they have 2. Because when we share, we both feel like we get the toy, right? This is called a covalent bond. And it's a strong bond. When they share electrons, it's a pretty strong bond. Now, there are 2 other ways to draw this. Okay? There's this way with the E's. The simpler way is called the dot structure. So we're going to represent electrons with dots.
Could we get all cross-country runners to head towards the north end of the building? That's down the E hall, down by the...
We are going to represent the electron around hydrogen with a dot. That hydrogen has 1 electron. And the other hydrogen has a dot. So we will represent that with 1 electron. Now, what I like to do, and you can do this too, is I like to use 2 different colors so I can see which electron belongs to who. And then I can circle this and say, okay, here's this hydrogen's electron, here's this hydrogen's electron, and where are they sharing? Here's where they're sharing. Okay, they're both sharing those electrons. Alright? That's the second way you need to draw this, using the dot structure. The first way is written for you. Here's the second way. The third way is like this. Okay? It's the line structure. To represent a single electron that is being given by this hydrogen and shared by this one, okay, shared by either one, a single electron being shared is represented by a single line. That's a single covalent bond. Okay? So, those are the 3 ways it should be written on your paper. I gave you that one. You should be able to write it, and you don't have to have the circles, but you should be able to write it using the electrons, what's being shared, and you should be able to write it like that, knowing that this is a single covalent bond between the hydrogens. Okay? I will do 1 more with you, and then you need to do the rest. Okay? The second one. We're going to do number 5. Number 5's down here. It's CO2. Okay? So on CO2, number 5.
Exit the campus immediately. All cross-country runners, you are to be on the north end of the campus in the gym area. Please move yourself that way now.
CO2. Okay? CO2. I've got 1 carbon, 2 oxygens. So where's carbon going to be? It's going to be in the center. Okay? It's going to be right in the center. That makes sense. There's 1 of them and 2 of the other. Okay? They get ganged up on. It gets sandwiched. Now, question. How many electrons does carbon have in its valence shell? If you don't know, look on your chart. Okay? It's got 4. 1, 2, 3, 4. Okay, that's carbon. It's got 4 valence electrons. How many does it need? So I know what we have. We have 4. How many do I need? I need 4 more to fill my second shell. Now, I didn't draw the 2 electrons on the inside shell because I don't care. They don't help me here. It's full. So carbon needs 4. Now, who else is coming to the party? Well, 2 oxygens. So who else is coming? 2 oxygens. Alright? How many does carbon need? 4 more. So how many will each one bring? 2 each. That will make carbon happy. Okay, so I start by draw the 2 electrons that oxygen will bring to carbon right there. So I know these are being shared. These are being shared. Now, carbon's happy. 4, 8. Problem. Oxygen doesn't just have 2 electrons, right, in its valence shell. From your paper, you should know it has 6. So I have to account for those electrons as well. In accounting, if every dollar is not accounted for, you got problems. Same thing here. If I don't account for every electron, I have problems. So I have to account for all 6 of oxygen's electrons. However, it's only sharing 2 with carbon because that's all carbon needs. This one's only sharing 2 with carbon because that's all carbon needs. How many does carbon think it has? 8. How many does oxygen think it has? Count them. 2, 4, 6, 8. How many does this oxygen think it has? 2, 4, 6, 8. It's happy. Now, question. How else do I draw this? Okay? To represent when each atom is sharing 2 electrons instead of just 1, like with hydrogen gas, I've got carbon in the center, and I represent that with double bonds. This is a double bond. They're sharing 2 electrons each, so it's a double line. That's the third way it should be written. I gave you that one. You need to draw the electron structure. That's the third way. Okay? You do the rest. Using your chart, knowing how many valence electrons it needs, and asking yourself the 4 questions. How many do I have? How many do I need? Who else is coming to the party? And so how many will they bring? You should be able to do the other drawings. Okay? When the paper's done, turn it into me, and you'll be good to go. You should be able to answer the other questions on the back side. Okay? If you need to know how to do an ionic bond, look it up on Google and try it, and then come in and we'll work through it on our own. Okay? Go Cardinals.